Hello students, welcome to this video where we're going to discuss the product and quotient rules. So with the product rule, I've provided you a description here. The derivative of the product of two differentiable functions is equal to the first function times the derivative of the second plus the second function times the derivative of the first. I'm going to write this out symbolically for you, and I'm actually going to switch it around. So it's going to be written differently than the description, but it's just to show you that you're doing addition. So the commutative property applies here. So it does not matter what order we add our derivative and same function in. So this is stating I'm looking for the derivative. I got two functions, they're being multiplied together, and I want to find their derivative. So I'm going to find the derivative of f and leave g, and I'm going to add that by leaving f and finding the derivative of g. So notice in each term that I am finding the derivative of my f, and then in the other term I'm finding the derivative of the g, and then in the first term I'm keeping one of the functions the same, and in the second function I'm keeping the other function the same. Okay, so pretty easy to kind of think about here. So I want to give you an example. Let's say that you have a function, and we're going to call this h of x, and it is equal to x squared minus 3 times x cubed plus 5x. The idea here is that I can identify an f function, so I can call this part my f, and then I can call this part my g. So I have two functions. They are standalone functions, and they're being multiplied together. So I'm going to want to plug these into their respective formulas. So I like to go off to the side, and I like to write my f, which is x squared minus 3. And so my f prime, using the power rule, would be 2x. And then I'm going to write my g function, which is x cubed plus 5x. And I'm going to write my g prime function, which is 3x squared plus 5. And then I use all of this information to plug into my formula, which says f prime, which is 2x, times my regular g, which is x cubed plus 5x, added to my regular f function, which is x squared minus 3, times my g prime function, which is 3x squared plus 5. And so I'm going to need to simplify here. So I'm going to distribute in my 2x to both terms, and that ends up with 2x to the 4th power plus 10x squared. And here I'm going to need to FOIL. So that is going to give me 3x to the 4th power plus 5x squared minus 9x squared minus 15. And then if I combine my like terms, I end up with 3x to the 4th minus 4x squared minus 15. And that is being added to my 2x to the 4th plus 10x squared. And now looking at the entire polynomial, I can combine like terms again. So I have a 4th degree and a 4th degree, a squared degree and a squared degree. If I combine those terms, I end up with the final answer of 5x to the 4th power plus 6x squared minus 15. And this represents the derivative of my original function. And so that would be my final answer. Okay? So again, you're literally just doing f prime times g plus f g prime. All right, let's look at another example. Let's say that I give you some function, and that is going to be 2 over x squared, and then minus 5x plus 1. And we're going to multiply this by x squared minus 8. So again, I'm going to want to identify my f function and my g function. So I'm going to identify my f function as this first function. But I notice that I have this fractional term here, 2 over x squared, And it's not going to be easy for me to find that derivative if it's written in that format. In fact, we do not yet have a process to be able to find that. So I'm going to rewrite that using negative exponents. So this is the same thing as 2x to the negative 2 minus 5x plus 1. Notice that I've not changed anything about the problem. And then I can find f prime, which is just going to be negative 4x to the, let's see, I am subtracting 1, right? Negative 2, so negative 3 minus 5. Yes, sorry. I was trying to think about that. I was like, is that correct? That is correct. Okay. And then I have my g function. I'm going to identify that as the other portion. And that is x squared minus 8. And so my g prime is going to be equal to 2x. And now I'm going to plug everything together. So I have f prime, which is negative 4x to the negative 3, and then minus 5, times regular g, which is x squared minus 8, added to my regular f, which is 2x to the negative 2 minus 5x plus 1, times my g prime, which is 2x. And now I'm going to want to go ahead and simplify these. So if I FOIL these two terms, I end up with negative 4x to the negative 1 plus 32x to the negative 3 minus 5x squared plus 40. And if I distribute this monomial into this trinomial, I end up with 4x to the negative 1 minus 10x squared plus 2x. And if I begin to combine like terms, I have the negative 1 powers here, I have my squared powers here. Those are the only things that can be combined. But these terms end up canceling one another out. And I'm left with 32x to the negative 3 minus 15x squared plus 2x plus 40. And because I want to make sure that I write the final derivative in its simplest form, I'm going to go ahead and get rid of my negative exponent. So I have 32 over x to the positive third minus 15x squared plus 2x plus 40. And there is your final derivative answer. And that is how we utilize our product rule. And so the next rule we're going to go to is our quotient rule. The derivative of the quotient of two differentiable functions is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. So to put that into terms for you, you have some f of x and it is being divided by some g of x. Actually, let me rewrite this. Oh, wrong one. Let me rewrite this for you. I have some f of x and it is being divided by some g of x. And I am trying to find the derivative of these. So I'm going to take the derivative of my first function times the regular part of my second function, subtract it from the regular f function times the derivative of the g function. I'm going to stop here for a second because I want you to notice that this looks very similar to product rule, right? So I took the derivative of f in the first term and I'm taking the derivative of g in the second term. I am keeping one of my functions the same in the first term and I am keeping one of the functions the same in the second term. So it's literally exactly what the product rule says. The only difference here is that instead of adding, I am subtracting. Okay, so pretty easy to remember. And then the catch that a lot of people forget is that I need to make sure I take g of x and whatever that function is, I'm going to square it in the denominator. Okay, so when you do quotient rule, you generally will end up with some type of fractional value. Okay? So let's look at an example. I have some function x plus 1 all over 2x minus 3. So like before, I want to identify an f portion, and then I want to identify the bottom as my g portion. I'm going to go off to the side, and I'm going to write my f as x plus 1. So that means my f prime is equal to 1. I'm going to write my g function, which is 2x minus 3. So my g prime function is just 2. And so now I'm going to use all of this to plug into my formula. So I have f prime, which is 1, times my regular g, which is 2x minus 3. And I am now subtracting that times my regular f, which is x plus 1, times g prime, which in this case is 2. And then all of this is being divided by whatever my regular g is, which is 2x minus 3. And I'm going to square that entire function. And so now I need to simplify. So looking at my numerator, I'm multiplying 2x minus 3 times 1, so that's just 2x minus 3. Minus, I need to distribute in my 2, so that's 2x plus 2, all over my 2x minus 3 all squared. But notice that you are subtracting a function, so that negative sign needs to distribute in. So I get 2x minus 3 minus 2x minus 2 all over 2x minus 3 all squared. And I notice that I have a 2x and a negative 2x, so I know that those are going to cancel one another out. And I'm left with negative 3 minus 2, which is just negative 5, all over 2x minus 3 all squared. And you're not required to actually square that through. You could. It wouldn't be counted wrong if you did, but you're not required to. And so this right here represents the final derivative using the quotient rule. Okay? Alrighty, let's look at another one. Let's do our function, x squared plus 5 divided by x cubed minus 2x plus 16. So like before, the numerator is representing my f, the denominator is representing my g. Therefore, I'm going to go off to the side, and I'm going to write my f function, and I'm going to write my f prime function. And then I'm going to write my g function, and I'm going to write my g prime function. And now I can use that information to plug into my formula. So I have f prime times regular g, which is this x cubed minus 2x plus 16. And because I'm using quotient rule, I'm going to subtract. And then I have my regular f times my g prime. And then all of that is being divided by whatever my g value is, all squared. And luckily, again, you do not need to expand the denominator, so you'll get to leave it like that. And we're going to take our 2x, and we're going to make sure that we distribute in, and then we're going to need to FOIL on the other term. So that is going to end up with 2x to the 4th power minus 4x squared plus 32x minus, and this binomial on this side is going to get me 3x to the 4th minus 2x squared plus 15x squared minus 10. And I'm going to want to simplify that to the 3x to the 4th plus 13x squared minus 10. And I need to distribute in that negative, so I have negative 3x to the 4th minus 13x squared plus 10. I'm going to bring down my other side, 2x to the 4th minus 4x squared plus 32x. I'm going to make a little note here. This is numerator. Numerator simplified. And I can combine my like terms. So that's these two and these two. So I end up with negative x to the fourth minus 17x squared plus 32x plus 10. And so this is also part of my simplified numerator. So now, putting my numerator with the denominator, represents my final function's derivative. So again, the key is to make sure you don't forget that denominator. That's the most common mistake that I see on the test, is that everybody, knows what the product rule is, but at that final answer, they forget to incorporate that all of g squared. So make sure that you're being careful and don't accidentally leave that off. As always, I hope you found this video helpful. If there's anything else that I can do to assist you, please don't hesitate to reach out.